The purpose of this presentation is to go through tips and strategies for taking the math portion of the ACT exam. The goals of this presentation is to help you achieve your highest possible score on the math section of the ACT. And why is this important? It is very important because your admission to college depends on your ACT score. The math class that you were taking, college, depends on what score you make on the ACT math part of the exam. So it's very important to work to get your math score up on the ACT, because which math class you start off in depends on that ACT score. In college, sometimes you have to take remedial math, and that's why we want you score high enough score so you do not have to take remedial math. You say, okay, what is remedial math? Remedial math course are courses that you have to take in order to take the math classes that are required for your college degree. And basically the remedial classes are like what you learned in high school, Algebra 1 and Algebra 2. They're just called different names like beginning algebra or intermediate algebra. But so you really want to work hard to get your score up on the ACT math, because a lot of things depend on it in the long run. What scores are possible? Well, the perfect score is a 36. National average is 21. And if you go down through there just guessing, that you usually make about a 10. Top 4 factors that influence your score on the ACT math is achievement. How much achievement deals with your studying and learning the math in high school. Really taking the time and really understanding the concepts. Being familiar with the tests. And we're going to talk about what is on the ACT math test and what kind of skills are needed. Test taking skills, which we will take a look at today, and anxiety level. Going through this seminar and going through prep classes, prep sessions will help lower your anxiety and be ready to take the ACT math. ACT general tips. There are no intentional trick questions. The directions are the same on every form of the test, right? Before you take the ACT math, you need to Google ACT math test direction and go ahead and familiarize yourself with that so it would save you time. They do not change the directions. No special patterns and answers. Choices are equally likely. Only one correct answer. You choose the best answer. And now the questions are random difficulty. A year ago, they changed the ACT. Well, used to questions 1 through 30 was your easiest, and then questions 31 to 49 was medium difficulty, and the last 10, 51 to 60 were the hardest questions on the test. However, now they are random difficulty. Number 5 could be the hardest question, so you can't count on that anymore. Just be prepared for any type of question. Now, when you're going on the way to your ACT test that morning, pick a letter of the day in your mind. This is only used when you absolutely have no idea what the answer is. Do not know the answer. So always pick the same letter if you do not know the answer, because chances are you will get one of them right if you stick with the same letter guessing. But never leave anything blank. Always use your letter of the day. Benchmark scores. These are very important. These are scores that, if you make in your sub areas, they are considered college ready. If you make 18 in English, you're considered college ready for English. Math is a 22. That's what you want to shoot for. Reading is a 22. Science is a 23. You really want to shoot for the 22 in math. If you go, for some reason, in junior colleges, I've seen throughout the years, they require a higher score than 22 to start off in the correct math class. And what math class most everyone has to take is a pre-calculus algebra. That's equivalent to the pre-cal in high school, but every major requires a pre-calculus algebra. And when you go into a four-year university, usually that is a good enough score, 22, to start off in that. For junior colleges, I've seen it's up to about 24. So you need to shoot from 22 to 24 on the ACT math to make sure you start off in the correct pre-calculus and not have to go back to intermediate algebra, which is equivalent to algebra 2 in high school. So you want to shoot for 22 to 24. Okay, what is on the ACT math test? Okay, these are the categories, two main categories: prepare for higher math and integrating essential skills. Now, under prepare and higher math, we have all these categories, but prepare for higher math, that is the math that you learn in high school, grades 9 through 12. Integrating essential skills is the math that you learn in middle school. 60% of the test is made up of high school math. 40% of the test is made up of the integrating essential skills, which is equivalent to middle school. Now, that might excite you that 40% is middle school. But because this comes from middle school content, these are difficult questions because they believe since students solve this material in middle school that they should be experts at it, so they make these questions at a difficult level. Okay, so even though it says middle school integrating, there are some difficult questions in that. So 60% comes from high school, 40% comes from middle school. Now, in that 60% of high school, they break it down to the high school math into 5 categories: number and quantity, 7 to 10%; algebra, 12 to 15; functions, 12 to 15; geometry, 12 to 15; and stats and probability, 8 to 12%. Majority of tests come from these categories. This right here, this is what causes students a lot of trouble, stats and probability. Unless you've taken a stats class or remember everything from middle school in stats and probability, that is somewhat difficult. And you will have a video on stats and probability later on. How to attack math problems. Okay. You're going to read the question part of the problem first. Always read the question stem first to see what are you actually looking for. Then read the entire problem from beginning to end. While you're reading that problem, pull the math out. And what I mean by pulling the math out, underline important things, or in your ACT booklet, you can write in. So while you're reading the problem, writing down important things, and then do the math and check your answer. Did you answer what was being asked? This goes along with the Kaplan 3-step method for the ACT math. Okay, and I'm about to review what I just did a while ago. Step 1: focus first on the question. Read the question stem and make sure you understand the problem. After you do that, it says do not pay too much attention to the answer, but I do suggest you give them a quick glance, because after you read the question and glance at the answer choice, you know what form they want the answer choices in. And what I mean by form, sometimes, let's say for example, you have area of a circle, pi r squared, and you work all that out, radius squared times pi, and you say 3.14. Well, they might have not multiplied by 3.14. They might have left it number times pi. That saves you time when you see the answer choices. So make sure you look at the answer choice. So read the question stem first. Glance at the answer choices. Okay? Then go back through the problem and read the entire problem, pulling out the information. That's important. Step 2, analyze. This is where you plan an attack. There's three ways you can attack a math problem in ACT. And one of these ways always works. One way, use your math skills. What I mean by that is using something that you learned in high school. Like if a problem requires you to multiply by the conjugate or factor, that's stuff that you learn math skills in high school, using math skills. Pick numbers. Pick numbers is, for example, this is where I would use a pick number. Let's say there's problems on the ACT that says let x be an even number, let y be an odd number. What is the product, or what is always true? Something like that. When they say let something be an even or let this number be odd, just pick an even or odd number, or pick a number that satisfies the conditions and plug them in. And the last thing is back solving. These are your 3 plan of attack. So math skills, use something you learned in high school. 2, pick numbers. Pick a number that satisfies the conditions given and plug it in. Back solving. Okay, when you back solve, that's when you take your answer choice. Always start with the middle answer choice, because once you do that, the middle answer choice is always in between the highest and lowest number, so you know to either go back to AB or down to DE or so forth. So back solving. Step 3, select. Once you get your answer, look at your answer choices and select the answer. Eliminate as many choices as you can when possible. So your Kaplan 3-step method for math is step 1, understand. Read the question, know what you focus on, go back and read the entire problem, pulling the math out. Step 2, analyze. Choose a plan of attack. Use your math skills, pick numbers, and back solve. And step 3 is select your answer. Make sure your answer makes sense. Here are some more quick tips for math. You need only to get 40 correct answers to get your math score over 25. That's awesome. Get your easy points first. Keep your pencil moving. Now, when you take the ACT booklet, ACT test, you can write in your booklet. I suggest that you, when you do 2 pages time, like there's a page over here and a page over here, circle your answers in the booklet, and then once you finish 2 pages, get your answer document and transfer those 2 pages into the answer document. Because when you select an answer and have to go over your answer document, you're wasting time trying to find, but once you do 10 at a time, you can go down and fill it out quickly. Don't let anything slow you down. Take control. Change your use your strategy. In math class, we often, math teachers guilty like myself, are making you show all your work. Here, you don't have to show all your work. Get to the answers as quick as you can. That's what I mean by don't be an obedient student. You don't have to show all your steps in the test booklet. More quick tips. When plugging negative numbers in your calculator, make sure you put them in parentheses. For example, if you put negative 2 squared in the calculator, you need to put that in parentheses or it's not going to give you the correct answer of 4. If you need to take a random guess, guess the letter of the day. This will increase your chance of getting some points. When doing trig function, make sure your calculator is in degree mode unless the answers contain pi, in which you are to use radians. Okay, so now we have went through the Kaplan 3-step method of taking the math portion of ACT. Now we're going to go through some things that are commonly found on the ACT. Commonly found. Know your formulas. One of these appear every time on the ACT, the distance formula or the midpoint formula. You need to refresh your memory on these. Now, on the ACT, they're not going to ask you just what is the distance. You can see like what is the length. If they say what is the length of the line segment, that means distance as well. Midpoint. They could give you 2 endpoints and tell you to find the midpoint in between the 2 endpoints. Or they could give you an endpoint and the midpoint, and you have to work backwards to get that other endpoint. So that's how you can see distance and midpoint on the ACT. Know these formulas: a quadratic formula and slope formula. Often you will find a question about slope. You use this formula, or you could use the formula rise over run if they give you a picture. Either one of those would work for slope. Often we see the words real number in problems, and we want to make sure you know what real numbers are. Those are all the numbers on the number line. Fractions, decimals, whole numbers, positive, negatives. Those are real numbers. All numbers on the number line. Don't let that throw you off. Rational, irrational. Remember, a rational number is anything that can be written as a fraction. It's easier to remember what is irrational because everything that's not irrational is rational. Irrational are square roots of non-perfect squares. Like we cannot determine the square root of 8 off the top of our head. That's irrational. And a decimal that keeps going and going, does not repeat, is irrational. And remember, famous number pi is irrational. Everything else is rational. Which of the following is a rational number? Do we know the square root of 2? No. Off the top, that's irrational. Square root of pi, we do not know that one. Square root of 7? No. Okay, when you have a fraction, do you know the square root of 5 off the top of your head? When you have a fraction, you take the square root of the numerator and the denominator. Well, I do not know the square root of 5, so this is rational because square root of 64 is 8, square root of 49 is 7. That is rational. Remember, a rational number is any number that can be expressed in the form of a fraction. Imaginary numbers. Unless you've had taken Algebra 2 with trig or pre-AP Algebra 2 with trig, you might not be familiar with imaginary numbers. Imaginary numbers came about to handle situations when you had a negative under a square root. In the real world, you cannot have a negative in the square root, but in the imaginary number world, this is equal to a plus or minus 2i. That I takes care of that negative. And you're starting to see more questions about this on the ACT. I squared is equal to -1, and a complex number is in the form of a plus bi. But if you haven't taken Algebra 2 with trig, this will be coming later on in your high school career. Proportions. There's always usually a question about proportions. And you notice a proportion when it's comparing one situation to another. For example, if a car traveled 275 miles in 5.25 hours, how far would it travel in 1 hour? See, it's comparing that situation to another situation. That is a proportion. When you set up a proportion, make sure if you start with miles or whatever you start on top with, the numerator in this fraction must be in the numerator in this fraction. And then you cross multiply and solve it from there. Inequalities. Remember, when you're solving inequalities, less than, greater than require an open dot. Less than or equal to, greater than or equal to require a closed dot when graphing on the number line. Remember, if you multiply or divide by a negative number, the inequality flips around. So make sure, turn that inequality around. Rules, powers, and exponents. Remember, product rule. When multiplying like bases, you add the exponents. For example, I'm multiplying like base x, I'm going to add the exponents. 3 plus 2 is 5. When dividing like bases, you subtract. A negative exponent, if you have a negative exponent, you put a denominator. If it's in denominator, you bring it up. Negative exponent, wherever it's at, it goes opposite. If it's in the numerator, denominator. Denominator, numerator. Power rule, a power raised to a power, you multiply. 2 times 6 will be x to the 12th. That's up here in a lot more of the rules. Logarithms. If you have not taken Algebra 2 with trig, this is coming. This is coming. But let's talk about this for a minute. This is called exponential form. Exponential form because I'm writing this using an exponent. I'm writing this using an exponent. My base is 6. My exponent is 2 equals 36. This is the exponent. The whole thing is called a power. Well, the inverse of this power is a logarithm. Now, let me show you how this is written in logarithm terms. Log base 6. This is known as base. This is your base down here. So you put the exponent on the other side. So you see this is 6 squared is 36. That is the equivalent. 6 squared is 36. 6 squared is 36. That's how you write it in the log world. Okay? And if you take an Algebra 2 trig, you remember the product rule. When you're adding, you multiply these. If you're subtracting, you divide them. Functions. Remember, a function is a special relation in which each member of the domain is paired with exactly one member range. This x has one member over here. Over here, this is not a function because you see 5 right there has more than one arrow coming from it, so that makes it not a function. Composition of functions are big on the ACT. You got f of g. Remember, you can see f of g like this or like that. Either one means the same thing. The x is closest to g. You plug whatever's in here into g first and get that solution, and then take that and plug into f to get your final answer. For example, here, f of g. G is on the inside. You take this, plug it into f, and that's what they did there. And follow order of operations. Something that comes up a lot, you hear the word parallel and perpendicular lines. For example, write an equation that's parallel to this line. Well, you need to know that parallel lines have the same slope. Perpendicular lines are lines that have negative reciprocal or opposite reciprocal. For example, if this line had a slope of 2/3, the slope of the perpendicular line, you flip it and change the sign, be -3/2. Let's say we had -5. If I wanted the slope of a perpendicular line, I flip it and change the sign. It would be 1/5. So making sure you review your parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular, negative reciprocals. That means you flip it and change the sign. Triangles. Reviewing what type of triangles. Remember, this is the equilateral triangle. All 3 sides are equal. Isosceles, two sides are equal. Scaling, no equal sides. Acute, all three angles are less than 90. Right triangle, one is equal to 90. Obtuse, one angle is greater than 90. That's very important to review this. They ask this in all types of questions. Here's your 45, 45, 30, 60. Right triangle rules over here to 45. This is how, remember, two angles are the same. Both of these legs are the same. They are x, and then the hypotenuse is x squared root of 2. In a 30, 60, the angle across from 30 is x. The 6 one across from 60 is x squared root of 3, and the hypotenuse is 2 times x. The big thing about circles, you can review the part circle, is equation of a circle. Knowing this, the equation of a circle. For example, here's the equation, x minus h squared plus y minus k squared equals r squared. But let's look at one. Let's say this, we have this as the equation of a circle. The center of the circle are these numbers right here. And it's the center of a circle is going to be an ordered pair. The sitting in the x parentheses is your x coordinate. Now, the only thing is, when you look at it, it's opposite of what you see negative 5, but it's positive 5. You see negative 3, it's positive 3. That's the center of the circle, 5, 3. The radius is the square root of this. Square root of 16 is 4. Let's look at another one. Alright, the center of the circle would be, you see positives, be negative 2, 6, that's the center of the circle. The radius is always the square root of this number. I do not know the square root of 5, I leave it square root of 5. Let's say we had this one. Okay, there's no parentheses there. If there's no parentheses there, it means that coordinate is 0. Opposite of negative 3 is 3, and the radius will be the square root of 25, which is 5. So that is how you read the equation of a circle formula. So take a moment to look at that. Pause if you need to. Remember, you can pause at any time in this video. Next, Pythagorean theorem. Remember, a squared plus b squared equals c squared. A and b are your legs. C is your hypotenuse. C is always your longest side. These numbers right here are known as Pythagorean triples because those satisfy the Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. 5 squared plus 12 squared plus equals 13 squared. 6 squared plus 8 squared equals 10 squared. 7 squared plus 24 squared equals 25, and so forth. Familiarize yourself with these, so if you run into that situation, you don't have to work it out, and you know those. But hey, always work it out if you're not sure. But those are known as Pythagorean triples. Area formulas. They do not give you your formulas anymore in the ACT, so you need to refresh this. Remember, square is side times side. Rectangle, length times width. Triangle, 1/2 times base times height. Parallelogram, height times base. Trapezoid, 1/2 times height times base 1 plus base 2. Circle, power squared. And rhombus is 1/2 times diagonal 1 times diagonal 2. So refresh your memory of these before you take the ACT. Here are some volume formulas. Now, hold on. We're going to go back to something. Area. How do you? Sometimes they don't ask you. They could ask you in another way. Sometimes they don't come out and say find the area. Sometimes they might say how much is needed to cover the floor. When you say cover, that means area. If they say fill up, that means use a volume formula. Here's some volume formulas. Cube. Side times side times side. Side cubed. Rectangular prism. Length times width times height. Sphere, 4/3 times pi r cubed. Cylinder, pi squared, pi. I think that should pi r squared h. I left the r out. Cone, 1/3 times pi r squared h. And then right square pyramid, 1/3 side squared height. Distance times formula. Sometimes they ask for the rate rate the person was traveling, or how long it took them, or what distance. The formula is D equals rate times time. They call it speed here. Speed times time, either way. Now, if they give you time, if you're looking for time, you can say distance divided by S. That's just a way of manipulating this little pyramid here. Distance equals speed times time. Time equals distance over speed. Speed equals distance over time. So if you just learn this one, then you can manipulate it for whichever one you need to find. Trigonometry. Unless you've taken Algebra 2 with trig, the 4th 9 weeks of algebra, you start seeing this stuff in 4th 9 weeks of Algebra 2 with trig. Now, in geometry, you should have seen this. You need to remember this. Sine, cosine, tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You use these when given a right triangle and you're looking for angles or sides, depending on what you remember. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. So please review that. Unless you've taken 4th 9 weeks of Algebra 2 with trig or pre-AP Algebra 2 with trig, you will not be familiar with these, but these are appearing a lot more on the ACT. It's particularly this one right here. And you might not understand this one right here yet, but if you learn this just like you learned Pythagorean theorem, a squared plus b squared equals c squared, then this will make sense later on. Just remember, sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. And in future videos, you're going to see where this problem, where an example of this will be used at. And I will show that later on. But just from the video, remember, sine squared plus cosine squared equals 1. That's very important. Alright. Before we end this first video, I just want to go back through the Kaplan plan for taking ACT Math. Step 1, read your question stem first. Glance at your answer choices. Step 1, read your question stem first. Glance at your answer choices. Then, step 2, go back to the problem. Read through the problem, pulling at the math, underlining the important math. Then picking and problem of attack, plan of attack. Use your math skills, pick numbers or back solve, and then select your answer. Going back through it, step 1, read your question stem. You got to understand the problem. Read the question stem, glance at your answer choices. Step 2, analyze. Read the entire problem, pulling the math out and choosing a plan of attack. Your plan of attack could be use your math skills, pick numbers, and back solve. And step 3, select your answers. Now, in future videos on the Google Classroom, I'm going to work through problems that come from each of these major categories, and I'm going to demonstrate how to use this plan of attack to solve problems. But each video will be named by the domain: number and quantity, algebra, functions, geometry, stats and probability, and integrating essential skills. So I will update these videos. I will post these videos on Google Classroom. Thank you.